Okay, everybody, welcome to our session. A little housekeeping before we get started. We're going to try to keep this to a 1-hour session. For those attending, there will be certs automatically sent to those who have attended. Let's see, there's going to be a no poll question kind of inclusion today, but if you do have questions, there's a question section in your control panel on the GoToMeeting. Feel free to lob questions and we'll take and answer those questions either when convenient or there is going to be a Q&A session at the end. We'll leave time for that. So without that, any other type of housekeeping, I'm going to get into the introduction. Surface Tech is proud to host this webinar series. It's number 2 of 3. We felt in conjunction with Intelligent Concrete that ASCM, or Alternative Supplementary Cementitious Material, is an important topic to bring awareness and understanding to this category, especially in light of industry issues plaguing our immediate runway, such as quality of aggregate and fly ash, which has little or no availability or very poor quality. So with these two issues, the ASCM category becomes much more important to the industry, especially by way of understanding, but more importantly, use. Today, the presentation is going to be headed by John Belkowitz, Dr. John Belkowitz. John is a PhD and a owner and research developer for Intelligent Concrete, with he and his wife Whitney own and manage, and they are a global force in the industry with regard to awareness on especially the innovation of concrete issue. John's also a teacher, a lecturer, a card-carrying ACI and ASTM member, and is very much a steward in the industry and is looked at very highly and in all places high regards with regard to all things concrete and all things innovative in concrete. So without any further ado, I'm going to turn it over to Dr. John Belkowitz. John?
Thanks a bunch, Steve, and it is definitely a pleasure to be part of this presentation, especially segment 2. Segment 1 was a good time, but in segment 2, we go from that bookcrete to labcrete, where we start looking at the ideas of using these alternative supplementary cementitious materials. And that's what I have to do today, is to give you a quick peek on what we like to call the magical world of concrete, specifically looking at these alternative supplementary cementitious materials in concrete mix design. Next slide, please. Now, before I get into the meat of what we're talking about today, a quick little overview, background of who I am, what I do, and a research motivation. You know, why are we going after these alternative supplementary cementitious materials? And then after that, we're going to look at ASTM C1709 and the quality management portion of that ASTM that differs from ASTM C, let's say 618, what we would use for our Class F or Class C and even Class N fly ashes or materials, excuse me. And after that, what we're going to do is dive into gymnastics with algebra, the concrete mix decoded, looking at how we would use ASCMs, using Juno XP as an example, to do a concrete benchmark mix design, especially when we're looking at taking out our cementitious and replacing that cementitious, a large reduction cementitious, with a small portion of our ASCM, and making up that yield, that volume, with our coarse and fine aggregate. Excited to get into that. So without any further, yes, thanks, Steve. So like Steve said, my name is Dr. John Belkowitz. I'm the Director of R&D at Intelligent Concrete, where we specialize in bringing new and emerging technologies to the concrete industry. Started my tenure in this industry through the United States Air Force, where I was placed in a civil engineering squadron to provide for parent sustained bases as a platform for the projection of aerospace equipment around the operational continuum. And through that, as well as my work throughout universities, commercial laboratories, I was able to take what I understood about how to get that technical transfer to truly happen for rapid deployment and early adoption. And when Whitney and I created this company, Intelligent Concrete, a decade plus ago, That's what we wanted to do, bring some of these new and emerging technologies that sometimes get lost in university basements out to the industry where they can save the world with all the concrete in it. Next slide. And that's ultimately what we want to do. And the research motivation behind this, next slide, falls in line with what we are and who we are as a company, but it's also surface tech. And next slide, please, Steve. And what surface tech brings to the industry. Surface tech is bringing these tried and true concepts, whether it's concrete or asphalt, or even these new construction apps that can effectively increase the efficacy, the efficiency of our day-to-day concrete recurring work cycle. Next slide, please. And this is why we do it. We're trying to solve today's problems with yesterday's technology. And because we do that, because we're relying on certain technologies that just aren't available to us anymore, we sometimes get caught in a vicious cycle of almost built-in obsolescence, where we're building structures that have to be either maintained or repaired or replaced before the tenure of their service life was expired. We have over 600,000 concrete bridges in our national inventory, establishing this over $48 billion a year industry. Of that, over $8.3 billion is put back into concrete every year to deal with the maintenance associated with chemical and physical attack. Now, I'm not saying concrete is broken, but we definitely need an enhancement, not only for the concrete, but for the raw materials, that we've been hanging our hat on for years. And I understand, as architects, as engineers, as specifiers, as scientists, in the concrete industry, we have to put a lot of time into it. What is this going to do to my concrete in 5 years and 10 years? And sometimes it's hard to make those decisions, but we have to start asking the right questions and start looking at the new technologies today, because in the next 5 to 10 years, we're going to start being forced to make some decisions because where our resources are going. Next slide, please. So what I'd like to do is spend some time on the purpose of segment 2. And I said it was bringing that bookcrete to the labcrete. And what I mean by that, it's not only looking at the practical side of this ASTM for these ASCMs, but it's also doing some of that math for using these ASCMs in concrete mix design. So we are going to look at 3 concrete mix designs. And of course, these are not exactly like your concrete mix designs, but these are benchmarks. And these are concrete mix designs that we feel you should see throughout the industry. Not only the workhorse concrete mixes, but also those high-end concrete mixes. Oh, thank you, Steve. So yeah, jumping into the purpose, unraveling the mysteries of alternative supplementary cementitious materials, we want to look at what the basic definition of an ASCM is in concrete, and try not to confuse it with the already matured technologies like our fly ashes. After that, we want to discuss why do we use those, or how do we use these ASCMs, and who are they used by. So let's just dive into it. And you'll see that next slide, that a lot of these slides have information with the references in there, and we wanted this to be a takeaway for you. We wanted you to be able to refer back to this. You'll get a certificate for attending this course, and with that, we also want you to have this information that empowers you to make different and what we think is better decisions out in the industry. So for unraveling the mysteries, an ASTM C1709 alternative supplementary cementitious material is defined by 1709 as the technical and economic benefits of SCMs have been recognized, and as the sustainability and environmental awareness result in the need to develop new materials and new ways to use materials not previously utilized, new sources of potential SCM are being proposed for use in concrete as ASCM. So that being said, there's a lot of new technologies, whether it's pet coke ash, hemp ash, corn husk ash. There's a lot of new and emerging technologies on concepts that might have been sitting on a shelf for decades that have the ability to make our concrete stronger and last longer. The reality is, though, in the past, we have not had these conduits, these ASTMs, to give our architects, engineers, and specifiers alike the confidence to use these new and emerging technologies. And when I say corn husk ash or petcoke ash or some of these other like finely ground pumice, a lot of these things have been around in the industry for a very, very long time. But again, they just didn't have that conduit. And ASTM C1709 gives us the ability, it's a guide for the evaluation of these alternative supplementary cementitious materials. And as one of the authors said, it is one of the most practical ASTMs out there, and you'll see why in a second. Next slide, please. So an ASCM, we're going to consider that to be a dry material that acts similar to, but does not meet the chemical and physical requirements as supplementary cementitious materials. Now, the ASTM, the 1709, specifically calls out that when these ASCMs do not meet the demand of ASTM C 618, 989, and 1240, and those are for those coal combustion residues or those natural ashes or materials. The 989 is for our slags, and the 1240 is for our silica fumes. So when we have materials that don't conform to those standards, we fall back on this ASTM C 1709. And what you see in front of you is a picture of Juno XP. And with that, I would like to take a second to thank Surface Tech for sponsoring this. There is a desperate need in our industry for this type of education. There's a desperate need in the industry to give our engineers, our architects, and our specifiers another tool in their toolbox to not only meet the demand of the recurring work program, getting concrete out the door, down the chute every day, but also to make our concrete stronger and last longer. So Surface Tech, thank you very much. And their flagship product for concrete is Juno XP, which you see right in front of us. Next slide, please. And it's a powdered material. It's an alternative supplementary cementitious material, as is the definition. Now, when we look at how do we use ASCMs, it's all related to choosing the concrete mix. Using ASCMs, you're primarily going after solving many of the problems that are identified in the industry. And that could be either chemical physical attack or as something as simple but so gosh darnly important, which is reducing the cost of our concrete by increasing the efficiency of our cementitious package and allowing us to reduce our cementitious. Now, bear in mind, before we do that, we got to identify our fresh properties and, again, understand those needs and those concrete pains so we can really get a grasp of what we need with our ASCMs. Now, please bear in mind that when using an ASCM, and specifically with Juno XP, we talk about cementitious reduction. That's one of the primary things that we talk about. And we talk about it because it not only has a value-added performance spin to it, but it also gives us a green footprint. We're saving the world with all the concrete in it. With all this information, we can make a balanced decision about how much cementitious we pull out, balancing it with the coarse and fine aggregate as well as that ASCM, and then keeping in line our other components, our water cementitious ratios, as well as our additives and admixtures. So next slide, please. So when we talk about how do ASCMs impact the concrete, we're focusing on not only the long-term, but also the long-term durability and the maintenance, but also the short-term fresh hardened properties, the maintenance and the enhancement that we get from Juno XP to help us out on the job site and start recognizing that value-added performance. And the first thing that I said that we focus on is that cementitious or that cement reduction for greener concrete. One of the things that we've been focusing on at Intelligent Concrete is trying to reduce the carbon footprint of a pavement concrete by 95%. And one of the methods that we chose that immediately went to was using Juno XP to reduce our total cementitious. Now, by doing that, we ultimately reduce the carbon footprint of our concrete which is something that's not only going to help us, but it's also going to help the future of our construction industry as well as the future of our planet. But what we get from that, what we get from using less cementitious and using more of this Juno XP is a concrete that is stronger and lasts longer. So what we get from that again is that cost maintenance reduction. You know, I spoke before about this national impact on concrete that we have. There's 8.3 or over $8.3 billion that's associated with concrete maintenance. There's something to be recognized about a revenue stream that can be recaptured. But not only that, more importantly, we have local and state municipalities that don't have the money for new construction because they're constantly paying for the maintenance and the rehabilitation of older construction. I don't care if you're in New York, New Jersey, California, Texas, or even in New Zealand and Australia, you see the same thing. You know, folks often ask me what concrete 2030 is going to look like, and I have a cynical answer that we're going to still be paying for concrete 2015, 2010, and even earlier by the time we get to concrete 2030. Now, one of the other things that we have to be cognizant of is using Juno XP is that it is going to make this concrete stronger and last longer, but it does have an impact on the fresh and hardened properties of concrete. Now, we take advantage of this to make that mix better, to make it stronger, to make it last longer. Next slide. But we also do it to take into account that one of the materials, especially here out in the Western U.S., that we've relied on for decades, and that's a Class F fly ash, that coal combustion residue. We can't rely on that anymore. And it's not like we're one of the 13 states that are no longer getting Class F fly ash. We do have our volumes, but the volumes that we're getting are random, and that's in quality. You know, the volumes that we're getting could be what you see in that cup on the right-hand side in the image in front of you, that nice beige colored. It doesn't smell of ammonia. It can be used at 15 to 25% replacement. It maintains the fresh properties. It gets us our ASR mitigation, so on and so forth, and our strength developed with no problem. But oftentimes our ready-mix providers see what's on the left, that struck match black fly ash that has some type of ammonia smell to it. When you add it to water, it has a rainbow sheen to the surface. And what it does is it compromises not only our fresh properties, but also our strength, and more importantly, the very mechanisms that enhance the concrete durability, whether it's air content that we have to constantly play with and rarely get right with these new Class F fly ashes, or the ASR issues that we have to deal with over shorter periods of time that we've had to deal with in the past. So when we talk about ASCMs, an alternative to what is what we've been trained to be used to and use in our day-to-day operations. And what we're not saying is, we're not saying we'll throw Class F fly ash tomorrow. Far be it from me to tell you what your principal engineers and professional engineers want you to do. But that harsh reality that I keep bringing up is, eventually you're not going to have that fly ash. And you don't need to believe me. What we started in 1978 with our renewable energy movement, we're not going to undo. And I don't care if you like our current president or not, but he's not going to turn those coal combustion plants on that we used to have in the 70s and 80s. You know, if you look on the horizon where I live, it's nothing but wind turbines. So eventually, we are going to go away from this coal combustion residue. And despite the fact that we can dredge it up from these ponds, we still have a subpar material than what we used to have. And if your engineer never wants to go away from that Class F fly ash, that's fine, because what we have found is Juno XP can be used to make it seem like a Class F fly ash from the 1970s and the 1980s, effectively increasing the molecular kinetics, the cement hydration to make that concrete stronger and last longer. Next slide, please. So who are ASCMs used by? Contractors, architects, engineers. I say the concrete structure as if it has a decision-making process. And of course, the concrete structure doesn't. But you know, concrete is like any other sport out there. You know, the ball never lies. And if you don't treat your concrete the way it's supposed to be treated, it's going to communicate to you especially as it manifests in premature failure, which requires premature tear out and premature replacement. We call it rip, strip, and replace. So who are these been used by? The people in the industry who feel the heartbeat of concrete, who understand where the concrete industry has been and seeing where it's going. And the reason why I like to put contractors first, and just falling back on the definition of a contractor is anybody who makes, delivers, or uses a material. And the reason why I put contractor first is because the ready-mix providers who fall under that contractor category, they know what the debilitating effect that the fly ash issue, this renewable energy movement that has officially caused what I call the concrete apocalypse, is doing to the industry today. And they know that there is a dire need, because I've got ready-mix providers asking me for letters that say it's okay that they make concrete without fly ash, even though they don't have that fly ash. And of course, I don't write those letters, but they still make that concrete and they still deliver it. And of course, it trickles down to the architects, civil engineers, and of course, the concrete structures, as we've already discussed. So who are these used by, these ASCMs? They're used by people who have to make the decision every day to make their concrete stronger and last longer. Next slide. And what I like about this 1709, and it was a few months ago that I started creating this with the folks at Surface Tech, that I started asking a lot of university folk, a lot of engineers, especially at the government entities, about the ASTMs and how they understood them. And one of the questions that I asked is about the quality of Class F fly ash that I get to see in the ready-mix industry here in the Western U.S. And one of the engineers, one of the university folks came back to me and said, John, show me where in ASTM C618 it talks about quality management. And for the life of me, I could not pick out that section. I could not find that section. And maybe I'm not interpreting it the right way. And if you're on this call and you can see the quality management portion of ASTM C618, I'd love to be educated on that. But what I do see out of ASTM C1709, next slide please, is a quality management portion. It's a quality management portion that focuses on making sure that what you're creating in the bookcrete matches what you find in the labcrete, and definitely is concurrent and consistent with what you're getting out to the real crete. And that is something that we just haven't seen on the Class F fly ash side, especially here in Colorado, Texas, New Mexico, Arizona, and California, is you order Class F fly ash, and what you might get is, and please excuse me for the joke, you might get cotton candy. And with Juno XP and other ASCMs that fall under 1709, there is a quality management portion that is required that focuses on the surety that we are creating a superior product and delivering a superior product to make that concrete stronger and last longer. So quality management, next slide please. Quality management systems defined actions necessary to assess admixture production and processes as a means to control the level of quality being produced in the end product. This concept of quality includes sampling and testing to monitor the process and the acceptance of sampling and testing of raw materials. And that's what we do, and that's what ASTM C1709 requires to a certain degree, is a testing and an evaluation of not just the finished product, but also raw materials, and almost keeping like a vintage book to see what the product is like over a period of time. And then once you meet that criteria, you can extend that period of time. Next slide. So this is at least a very top portion of ASTM C1709. This is for educational purposes only. And as the ASTM-C reads, it's a standard guide for evaluation of alternative supplementary cementitious materials for use in concrete. And it specifically states within this ASCM that it is to be used when other materials are not available that fall under those ASTMs that we are used to. Next slide, please. And one of those, of course, is ASTM C618, and we know it very well out here in Colorado. In that ASTM, for us, we use standard specification for coal fly ash, coal combustion residue. For us is class F ash. We do have class C ash out here, but we don't tend to use it as much. Folks out here really rely on that type F ash, especially to mitigate ASR. And here in Colorado, we have a pretty bad ASR problem. When I first moved out here, we're using 10 to 15% class F fly ash. By the time I started my PhD and some of our places in the mountains, we were using 25, 30, and 35% replacement with the class F fly ash. And eventually we stopped using those aggregates, and now we're hovering around somewhere between 25 and 30% class F fly ash. Next slide, please. So the milestones, the purpose of ASTM C1709 is to set up these 5 stages, these 5 milestones for characterizing and evaluating your material. And you have to go through these processes and make these available to the end users at any point, just like you would for an ASTM C494, an ASTM C618. But as you'll hear and see, there's a lot more that goes into this. So one of those milestones is characterization of the material. That's your raw material, the particle size distribution, the chemical analysis. It starts out on a very low level. And as you move forward through phase 2, you get to a higher determination of suitability of fineness. And that includes not only that particle size distribution, that chemical analysis, but what we have to do is use a background ASTM. Now, you can use 989 or 1240 or 618, and we chose to use 618. Now, just because you're using the 618, that does not mean that it has to conform to that 618. You just have to use that as a benchmark for the test that you're going to do and the data that you're going to report. Now, getting into phase 4, this is where it gets more into that practical side like I was talking about. Now, normally when you look at a 618, you don't see a lot of concrete tests in there. You see more of these strength activity indexes, and you might see, folks using these sulfate attack tests. But with the 1709, you have these true concrete performance tests that is akin to the ASTM C494, where you're setting up a battery of tests. It's a reference to an ASCM enhanced concrete, and you're comparing those two at a minimum over 365 days. Again, comparable to what we do with the 494. Now with Juno XP, we also included our sulfate test, so we extended that to 18 months. Now, remember, this is a guide to an evaluation. So whenever we give this to a new end user, we have to give all of this information. And right now, to me, we're in line with almost every other, to a certain degree, ASTM out there. And this 5th phase, this is where ASTM C1709 distinguishes itself as what my favorite title is, the practical ASTM, because it does require field trials, 3 field trials that are evaluated for 1 year each. And those field trials have to be updated to the end users when they get finished. So it's, again, the reason why I like this ASTM is because it does connect the bookcrete, the labcrete, and the realcrete to give architects, engineers, and specifiers alike the confidence to make those decisions for change in the industry today. And as an engineer, as a material scientist, I know the pains of the industry. I feel it every day. Juno XP to me is not snake oil. It's a concrete savior, because we have real pains and real problems that have already manifested, and they're only going to get worse. Next slide, please. So I feel like we've talked in nauseam about this coal combustion residue and how it is the unfortunate reality of the industry. We have a lot of specifically engineers who we need to convince. We need for them to have the confidence, because they are the ones who make part of the decision. If I go back to my military days, they are one of the decision makers who are turning the key. And without that confidence, they won't turn that key. So what we need to show them is how ASCMs can be used to bring back the unfortunate reality that we've been dealing with over the last decade minus. Next slide, please. And Juno XP, ASCMs answer those questions. Because they're new, they have to be evaluated more often. Because they're new, they have to meet a higher degree of this evaluation. We have to show you that there is a tenure on these. You don't have to worry about them, these ASCMs running out over the next few decades. We have to show you how they impact the physical properties of the concrete, the blended property, the chemical properties. We have to show you either 5 years or 10 years, which is very hard to do, but we have to show you through these accelerated tests that Juno XP, that these ASCMs are the key to making that 100-year project a reality. Next slide. What Juno XP has in it, what Juno XP is a two-part component. The first part, which is the secondary, is a pozzolanic material, which, as we know, consumes calcium hydroxide to develop more of the backbone of concrete strength, the calcium silicate hydrate. But Juno XP has an active component which increases the toughness of our hydrated cement matrix. It has a fibro-like morphology and a toughness greater than para-aramid fibers, toughness greater than Kevlar. It has a similar chemical makeup to the calcium silicate hydrate, and what we think is happening is that we're getting not only mechanical bonding between that mineral component, but we're also getting chemical bonding. So those catastrophic forces, those tensile and shear forces that would overcome the capacity of the hydrated cement matrix, we believe that the Juno XP is absorbing those tensile and shear loads to increase that capacity to make that concrete stronger and last longer, to help it maintain its structural integrity, not only under uniaxial compressive loads, but also under splitting tensile loads, direct tensile loads, flexural loads, as well as shear loads. And we also see it whether we subject it to ASR, freeze-thaw, de-icing salts and brines, but anything that cause an expansive pressure in the concrete that ultimately causes residual forces that overcomes that capacity that we just talked about. Next slide. Excuse me. So working through this 1709, we could see where there's, especially looking at the 618, where quality, consistency, and gray hairs aren't reflected in the 618. Yes, there are requirements from the 618 for strength, for absorption or water content, not water content, but water absorption, soundness, uniformity. But these requirements, they don't really give us an idea of what the product is going to do when we put it into the back of a ready-mix truck and we're trying to get gray concrete down the chute. Next slide, please. So what the ASTM allows us to do, because we have a higher degree of quality management, we can tell the vendors, we can show the end users that we have a data stream of quality management where they can make real-time decisions without having to guess what their delivered material is going to end up to be. And it's amazing that the folks who created this ASTM, and I really do give them credit for what they created, because it's a very difficult thing to get through this guide for evaluation of ASCMs. Your ASCM has to be at the top of its game if you want to get through this whole guide for evaluation and get it out to the market to make a true impact. Next slide. Okay, so I wanted to go into detail about the purpose of this presentation. I wanted to focus on the quality management, and what we can do through Juno XP is show you that data set to give you the technical data sheets, the SDSs, as well as that timeline of these materials. And then you can also see these different projects through our different publications about what's been done out there in the industry to prove the efficacy of this product. Now, outside of that, I would like to take the last portion of this presentation to look at 3 different mix designs, and I call it Gymnastics with Algebra. Next slide, please. So when you're looking at ASCMs, there's some things that we want to focus on. First of all, it's what is our total cementitious? You know, we want to know how much we're starting with. Is this a self-consolidating concrete? Is it made with a lot of cement, or has it already been optimized? And also, what you have on paper, does it translate to the truck? When you're making an exterior 4,500 PSI that's 4 to 6 inches with slump and 4.5 to 7.5, when you get to the job site, do they increase the water content, or do they put water in the back of the truck until they get to a 7-inch slump? What is the water cementitious ratio, and how does that translate to fresh properties? And that ultimately goes back to the type of aggregate. Do you have river rock that's nice and clean and absolutely beautiful? You have the same thing with your sand, or are you from Nevada and you have a manufactured rock, a manufactured sand with absorptions above 2 or even 3%? And then, of course, you know, going back to, is this concrete creamy and dreamy and easy to use to begin with, or are we already dealing with a mix that's unpredictable? Next slide, please. So the first mix that we're going to look at is this, what we can call conventional concrete for the residential construction industry. Falls into this category of 3,000 to 4,000 PSI. And if you're looking at ACI 318, you know, you can tack on another, 800 to 1,200 PSI on that, depending on if you have 3 years or 30 data sets to validate that strength. So we are looking for an F prime C plus our design or over design. We want to slump 4 to 6 inches, 4.5 to 7.5. And where we normally see this concrete being used, and I said it earlier, is that workhorse mix. The concrete that's used in our curb and gutters, or slab and grades, or foundations. Some of them are even in our garages, or our vertical walls for our basements. But it's really that 80% of the concrete that goes out the door every day. And with that, with the folks that we've been working with, and it's some of the top ready mix providers throughout the world, they look for $3 to $5 cost reduction per cubic yard if they're trying to get a new technology into the back of the truck. And the reason why they're looking for that enormous savings, and that is a pretty hefty saving, is because there's a certain risk that they have to take with getting that gray concrete down the chute, learning how to use it, teaching their folks, dealing with the issues associated when bringing a new technology into the plant. But next slide, please. This is the type of mix that we normally see out here for 3,000 to 4,000 PSI. 430 pounds total cementitious for our type 1-2 cement, 80 pounds for our class F fly ash. We have a nice river rock out here that we'll use 57, 67 with the maximum size of about 3/4 inch. We have a number 8 rock, a nice river rock, 300 pounds of that. We got some concrete sand. We're using our water at 320 pounds per cubic yard, and we're using some good high-range water reducers. We have a tendency of using those out here as opposed to our mid-range water reducers. We just have a lot easier times maintaining our fresh properties with those, as opposed to using a mid-range water reducer and having to increase the water on the job site. And then we're in our summer months, we oftentimes throw a hydration stabilizer. But out here today, when it's 19 degrees out, we got 12 inches of snow on the ground, we wouldn't be using that. Altogether, that cost per cubic yard is around $71.42. And that's material cost. That doesn't take into account the labor, the truck cost, the insurance, so on and so forth. Next slide. Now, when using Juno XP, what I wanted to do is break everything down on a volume calculation. And I'm really going after the absolute volume method here, where I have 27 cubic feet per cubic yard. And if I take this mix and I break it down to the volumes, I have a pretty significant volume here of 27.79. And we're using a water cementitious ratio of 0.63. And we could definitely go lower than that. But what we wanted to do with the Juno XP is reduce our cementitious by 15 and 22%. Now, what that means is I'm literally taking 22% out of my type 1, 2, as well as my class F fly ash. And as you can see with my volume calculations, I'm reducing those volumes, and I'm putting a small fraction in, or replacing that volume with my Juno XP. Now, the reason why I do that is because Juno XP has the ability to increase the efficiency of our cement by anywhere between 15 and 30%. Now, we can reduce the cementitious significantly, but the problem is at a certain point, if we don't have a good aggregate to paste ratio, we start going from creamy to dreamy to bony and nasty. So what I'm doing here is I'm making up that volume with my coarse and fine aggregate. Now, here's the catch. If you have a nastier aggregate, if you have a soft limestone that has a lot of fines to it, if you have a lot of clays in your aggregate, around your aggregate, it's dirty, if it's a manufactured sand, if it has a really high absorption, you're going to have to use more of the ASCM to compensate for that absorption that the rock and sand are going to bring to that mix. And it's not normally the water that they absorb, it's going to be the paste, but oftentimes what we do is to compensate for that, we put more water in. So what we end up doing when we're using these ASTMs that have the nastier aggregate, we set ourselves up for success rather than failure. So in other words, what we need to do is maximize the amount of ASCMs that we're using to minimize the amount of nasty aggregate that we're putting in. That being said, by using ASCMs, especially Juno XP, we have the ability to use nastier aggregates that are oftentimes inhibit us from moving on big projects and force us to bring in aggregate from other parts of the country. Next slide, please. Okay, so that translates. So we have our mixed design here and the original, the 430 and the 80. And as you can see, we're breaking those down. We're reducing those, that cementitious, by 15% and then 22%. And as you can see, we've got our Juno XP in there at 12 and 16 pounds per cubic yard. We're also increasing our rock content, not only our 67 or 57, 67, our number 8, but then our sand. And then this is one thing that I want y'all to be cognizant of, especially for Juno XP. This is not a cement-based material. It doesn't have the hydraulic component of that calcium oxide. So if we have a water cement ratio, you want to keep that constant, meaning that if you reduce your cement content and you keep your water cement ratio constant, you ultimately have to reduce the amount of water that's in the mix. Now, the same thing goes if you're using your admixture dosages at fluid ounces per 100 weight of cementitious, and you reduce your cementitious, ultimately you're going to be reducing your admixtures. And one thing that we found of the Juno XP is that it does enhance everything around it. And with all those reductions, we are seeing cost savings from everywhere that's $3 to over $4 per cubic yard. Next slide, please. So the next mix that we're looking at is a little bit higher strength of conventional concrete for commercial construction, 5,500 to 6,500 PSI at 28 days. And this is without that over design. A slump of 5 to 7 inches. Since we're out here in the Western U.S., we do need some air content, 4.5 to 7.5%. We've seen this used anywhere from slabs on grades, columns, some exterior slabs, some exterior geometries. But ultimately what we want to see out of this, because it has a higher degree of lawsuits to it, you know, folks often want to see a higher cost reduction to deal with that risk. Even though the ASCMs, especially the Juno XP, are making that concrete stronger and last longer, we want to see those higher cost reductions for that value added performance. Next slide, please. So as you can see with this, we got a higher cementitious content, 517 pounds total cementitious. We're using our Class F fly ash as before, and in this time, We're taking out that number 8 rock, so we only have the 5767 on our washed concrete sand. Both of these are river rock and river sand. We're using our high range water water content, as well as our 330 pounds per cubic yard. And then our high range area training and our high range or hydration stabilizer, just as we use, for a total cost of $87.10. And please bear in mind, that's only material cost. And Steve, can you jump down 2 slides? There you go, sir. So just as before, we broke down the volumes again, and with that, we're reducing that cementitious weight. So we have both our Portland cement and our Class F fly ash. So we have to look at the specific gravities, our unit weight, and identify how much we have to replace in our coarse and fine aggregate, and of course how much of our ASCM or our Juno XP that we're using. And with both of those, we can make a determination of what our benchmark mix design is going to be, and then of course dialing it in. Steve, you want to go back to that slide beforehand? Slide number 34. Thank you, sir.
I'm on to go. Can you call me back?
Yeah. And with that, we, just like before, for that conventional mix, we're reducing our total cementitious by 15 to 22%, increasing our rock and sand, and of course making our modifications to our water and our admixtures. Now, please bear in mind, these are all bookcrete. Conducting the mixes in the lab, conducting the mixes in the field, call it good concrete practices, but good concrete practices always dictate that we try out these things in a safer setting, something that has a lower impact to it. So if something bad happens, let's say if we have to dial in the mix, that what we did in the lab might be a totally different monster than what we're doing in the field. We have that chance to dial things in. And what we have found is time and time again, Juno XP has been very successful in meeting the demand of the job sites. Okay. Now, just for the sake of time, excuse me, just for the sake of time, we're going to jump into our last mix here. I want to just, Steve, if it's okay with you, I'd like to jump over to slide number 38. If you're already there, sir. Thank you. Look at that. You just read my mind. Now, this is an SCC mix that we've used out here in the past for demos that we've run for different agencies and ready mix providers. And again, like you see, we're taking that same approach, that 15 to 22%. And, the reason why you keep seeing that 22% reduction, it seems like a very awkward number. But since we've been going down this road of using Juno XP to meet the demand of the construction industry for value and performance, there's something about that 22% reduction that seems to be our magical number. And it's been awesome to see what we've been able to do with a whole variety of concrete mixes. And the time that I took today to show you these 3 different mixes doesn't even scratch the surface as to what you can do with Juno XP to save the world with all the concrete in it. And this mix design is self-consolidated concrete that we've used before, a 24 to 26 inch spread, a 26 to 28 inch spread, higher strength, 7,500 PSI plus or minus, still have that air and training agent in there. And as you can see, this is a much more expensive mix, and it's a mix that is more prone to segregation than the last 2 mixes that we've shown. And what we found with the Juno XP is not only does it help out with that value-added performance, the strength, the durability, blah, 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 but it also makes the concrete more robust. It gives you more forgiveness, especially when you're trying to get that SCC concrete down the chute into the form without going through segregation. And by doing that, by using the Juno XP, not only can we make that concrete more friendly, but how do you turn away a $5.26 savings and a $7.29 savings per cubic yard? With that, even if you don't believe anything that we have to say, with those cost savings, it definitely warrants you to try this out. And this is why I jumped on the Surface Tech bandwagon, the Surface Tech team. because their technologies meet the demand of the industry. They're disrupting the industry in doing what most other technologies cannot do, which is saving the world with all the concrete in it. Steve, do you mind jumping over to slide number 40? Now, I know I have a tendency of talking too much. I'd love to hear the sound of my own voice, but when I have to talk about Juno XP, I have to mention the amazing things that it has done for the future of concrete innovation. And it is disruptive. It is going to force our engineers to look at concrete in a different way. But what we have seen time and time again is that you can't not deny the cost savings, the short-term, and the long-term performance. The next segment, segment 3, is going to focus on those field trials. And we understand that the heartbeat of the industry requires baby steps. Heck, the decisions that we make as engineers, they last the rest of our lives. So the purpose of the next presentation is to show you, to prove to you, what the Juno XP can do and who we've been working with to make that concrete stronger and last longer, to bring a value-added performance, but more importantly, next slide, please, to save the world with all the concrete in it. I'm excited to answer your questions. If we don't get to them today, please feel free to email any of us, contact us on our website to get more information about Juno XP and how you can start using it tomorrow. Steve?
John, great presentation, very thorough, a very good book, lab, real creek type of a roadway that you painted for ASCM. Very good. Everybody that's on the call, there is in your control panel a questions section. If you'd like to type out a question, that would be great. If not, again, you can reach us at concrete@surface-tech.com. Feel free to reach out there, and we'll direct traffic to Dr. Belkowitz or ourselves to answer any of your questions. Again, certificates will be sent to you automatically as attendees to today's session. I see no Q&A at this particular point, John, so I think you did a really good job of explaining ASCM in a more thorough fashion to our attendee list. I'll keep the floor open for another couple of minutes. Otherwise, thank you for your attendance today, and enjoy your Thanksgiving. Be safe if you're traveling. Have fun with your family and friends. And we'll look forward to seeing you on segment 3 for this ASCM webinar series. Thank you, Dr. John Belkowitz.